All right, let's discuss the integration of even and odd functions. Now remember, historically, mathematics became more complicated in order to make life more simple. The shepherd in the field was trying to keep track of his sheep, and so he developed ways of counting. The first mathematicians, I firmly believe, were shepherds in a field. Well, it gets even more cumbersome, say, to count the population. So we have developed shortcuts and ways of making cumbersome, challenging jobs easier. Now, I personally love taking a big, horrible problem and sitting and beating it with a stick and coming up with an answer. All right, I'm strange. Probably need to do something on Friday night besides calculus, but that's all right. Oh, I do. I grade tests. Okay. Off topic. Now, in order to integrate even and odd functions, we just have some ways of making your life a lot easier, and it has to do with the symmetry of the functions. Now, go on and write this down. Let f be integrable on the closed interval minus a to a, because it doesn't make any sense if it's not. If f is even, and you remember even, a function being even means if you put in negative x, you're going to get f at x. So if I evaluate it at any point, a or negative a, I'm going to get the same answer. But if I integrate from negative a to positive a of f of x dx, that is the exact same as integrating from 0 to a of f of x. Why? Because this area is equal to this area. And we all know that integrating, having a lower integrand of 0 is a lot easier than pretty much any other number to evaluate. Now, if f is odd, then I know f of minus x is equal to minus f of x. And so this area right here is equal and opposite to this area down here, and they cancel each other out when you integrate from minus a to a. So no matter how ugly the function is, if you can show me it's odd, unless I tell you to use a different method, you have done what you've been asked, and you'll be able to just simply state that this function is 0. Now I would like to kind of go through the proof of this, because it's kind of interesting. It's a little bit slick. There is a homework problem doing the other one. And so let's look at f being even. So I know that f of minus x is equal to f at x. I know that. Now, suppose I want to use a substitution. U is minus x. Then du is minus dx. Let me look at the integral from minus a to 0 of f of x dx. And let's see what this becomes. Let's see, this is the same thing as, now I'm doing this u substitution we did previously. So this becomes the integral from from a to 0 of f at negative u minus du. All I'm doing is putting in my u substitution and changing my limits of integration. So this is minus the integral from a to 0 of, now f of u to u is the same thing as f of minus u. Now let me use this to flip my integrand here. So this is the integral of from 0 to a of f of u du, which is the same thing as the integral from 0 to a of f of x dx. Let me make my f a little bigger here. So the integral from minus a to 0 of f of x is equal to the integral from 0 to a of f of x. Now, you know I can write the integral from minus a to a of f of x dx as So I'm going to break this up into two parts, from minus a to 0, and then from 0 to a. Now, we've just shown that this is equal to the integral from 0 to a of f of x dx. Now, these two are the same thing. The proof for the odd one is the same. You only will have an extra negative sign in here, and things will wind up adding to 0. Now, let's look at an even function. Let's just look at an easy one. We know that cosine is even because cosine of negative x is equal to cosine of x. Now, let's integrate, say, from negative pi to pi of cosine of x. And let's see what that is. Well, the integral of cosine is sine evaluated at pi and negative pi. Now, this wasn't a really good choice because I'm integrating over the whole thing. But let's go on and do it. Sine of pi is 0. Sine of negative pi is 0, so this whole thing is 0. Tell you what if we integrate from negative pi over 2 to pi over 2? Can we do that? Cosine x dx. It's still, sorry about that, sine of x evaluated at negative pi over 2 and pi over 2. And what is this? This is sine of pi over 2 minus sine of negative pi over 2. And this is, what is this? So this is 1 minus a negative 1 or 2. All right, now let's integrate from 0 to pi over 2 cosine x dx. All right, and let's do a 2 here. And let's see if these two wind up being the same. So this is twice sine x evaluated at 0 and pi over 2. So this is 2 times sine pi over 2 minus sine of 0. And that's 0. This is 1. So my answer is 2. Okay, so the easy ones work. Let's do an odd one. Y is x cubed. I know y equals x cubed is odd because if I put in a negative x, I get a negative y. So let me integrate from, say, negative 1 to positive 1, x cubed dx. So when I integrate this, I get x to the 4th divided by 4, evaluated at negative 1 and 1. So I have 1 to the 4th minus negative 1 to the 4th, all times 1/4. So it's 1/4 times 1 minus 1, or 0. Okay, the easy ones, pretty straightforward. Let's do a more challenging one. Now we can do this integral. But first of all, what if we just see if it's even or odd? All right, so I'm going to put in negative x and see what I come out with. Sine cubed negative x cosine negative x plus sine of negative x cosine negative x. Let's see, sine of negative x is negative, so this is going to be minus 1 times sine cubed of x, cosine of negative x is cosine, plus negative 1 sine x cosine x. Let me pull a negative 1 out here. So this is sine cubed x cosine x plus sine x cosine x. Now if this is f, All right, then f of negative x is minus f of x. It's odd. Therefore, this interval equals 0. Boom, we're done. And if you don't believe me, go ahead and do this integral using substitution. Okay, give these a go. When you're done, turn off the video and finish your homework. Have a great night.